Hey guys, welcome to today's video where we'll be talking about molar mass. Molar mass is the quantity in grams that equals the atomic mass of the element. So let me just go ahead and paste the definition here for you guys as you see here. And in the last video we talked about how to calculate the moles. We can say that we have 4 moles of sulfur, right? And what is the atomic mass of sulfur? The atomic mass of sulfur is 32, right? Now we can say that there's 4 moles of sulfur. So we're just going to say that we have 4 sulfur atoms times the mass of sulfur, which is 32. If we punch that in our calculator, we get 128 grams. So this is kind of a quick example of how we calculate the molar mass. I have a few examples after this slide that we can go over, and hopefully you guys get a great understanding of molar mass. So if we scoot over, we have one that says, what is the molar mass of sulfur trioxide? Now, the first thing I like to do is go ahead and identify the elements that we have there. So first we have sulfur, and if we look at our periodic table, we have access to all of the masses, correct? So let's take a look at sulfur. Sulfur has 32. So we can write here sulfur 32, and then we have oxygen right here, and we can write 16. It says 15.999, but we can round that just to 16. So let me go ahead and just remove the periodic table for you guys, and now we can do some calculations. So how many sulfur atoms do we have? We only have 1. So what we'll do is we'll have 32 plus, now how many oxygen atoms do we have here? We have 3. So this is really written like this. That's how it's written. It's written like this because this application that I have only allows me to write it like that, but originally this is how it would look. So anyway, how many oxygen atoms do we have? We have 3. So now we can write 3 parentheses 16. And that 16 again is the mass of oxygen. So now we can do a little math. So now we have 32, and then 3 times 16 is 48. And then that gives us 80 grams of SO3, or sulfur trioxide. So this is our first example of how to calculate molar mass. Now if we go on to our second question, we have find the molar mass of Li2CO3, right? Which is also lithium carbonate. And this is used to produce red color in fireworks. So you see, you guys kind of get a little gist of, as to it's not just lithium carbonate, what is it used for, right? It is used to produce the red color in fireworks. So now how do we start this problem? Again, I like to start with all the elements that we have here. First we have lithium. I see we have a carbon, and then I see we have an oxygen. So we pull out our handy dandy periodic table here. We go over to lithium, Li, which is right here. Lithium is right there. I could pull out my pen. And we have 6.941, but I'll just leave it at 6.9. Now if we zoom back out, we can go ahead and write 6.9. How about carbon? Carbon, we have 12. So we can write equals 12. Oxygen, we did that before in the last example, and we said we'll round that up to 16. So oxygen will be 16. So now let's move this periodic table out of the way, and now we can start calculating. So how many lithiums do we have? We have 2. So we can do 2, and then the 6.9 plus how many, 6.9, and then how many carbons do we have? We just have one, so it'll be plus 12. And then oxygen, we have 3, and then the mass of oxygen is 16, the atomic mass. So now we can add all this together. So let's do 2 times 6.9, and with that we get 13.8 plus 12, because this was just one single carbon that we had there. And then we had 3 oxygens. So 3 times 16, 48. We add this all together and we get 73.8 grams of lithium carbonate. All right. So this is our second example, and you guys are kind of getting the idea here. You basically want to identify what atoms there are in that setup, right? In that molecular formula. And then you want to see how many atoms are available, whether that's 2, 3, or 1, and then we multiply and add across. If you guys are enjoying this video and it really helps, please leave a like, subscribe, do whatever you guys have to do. It really helps the channel as I continue to try to pump out so many videos to help you guys, quick and easy videos, all right? So now if we go into our third example, we have calculate the molar mass of salicylic acid, C2H6O3. Now, for this, again, let's identify the atoms. So we have a carbon, and then we have hydrogen, and we have an oxygen. Now we're going to identify how many of each atom. So there are 2 carbons. Oops, I'm sorry. I kind of skipped ahead of myself. We're going to actually write the atomic mass of each atom. So in the previous example, we know that carbon is 12 and then oxygen is 16. So we're going to kind of cheat there. 12, 16. And hydrogen, we know is the atomic mass is just at 1, as seen right here. It's at 1. So let's go ahead and move that out of the way, and we could get started to calculating. So again, hydrogen is right at 1. Yeah, so we just kind of made a mistake here. There is actually supposed to be a 7 there instead of a 2. So we're identifying how many carbons there are, and there are actually 7. So we can write 7, and we know that the atomic mass of carbon is 12. Plus how many hydrogens? We have 6 of them. So we'll do 6, 1, and then how many oxygens? We have 3. And if we go ahead and multiply across, 7 times 12 is 84, plus 6, because 6 times 1, 3 times 16, 48, and then we get a total molar mass of 138 grams of C7H6O3. All right. Now, in this example, we have rust, basically. This is a fairly simple one. So again, we're going to identify the atom that we have, iron and oxygen. If we pull up iron here, we can see that it has an atomic mass right there of 55.845, which we're just going to round right to 56. So right here we can write 56. And then for oxygen, we can write 16. So there's 2 iron atoms, so we can do 2 times 56 plus how many oxygens? 3. Oops, that is 16. And now 2 times 56 is 112, plus 3 times 16 is 48. And if we add these together, we get 160 grams of Fe2O3. Okay. For our last example, we have amoxicillin. This is an antibiotic that is used usually for stomach ulcers, things of that nature. And this is kind of a large one. So let's get started. Again, let's identify the different atoms. We have carbon, we have hydrogen, we have nitrogen, we have oxygen, and we have sulfur. Okay, so how many carbons do we have? We have 16. Hydrogens, we have 19. Nitrogens, we have 3. Oxygens, we have 5. And sulfur, we have 1. So now we can go ahead and set up our multiplication. So we know that we have 16 carbons, and the atomic mass of carbon is 12. We have 19 hydrogens. The atomic mass of hydrogen is 1. Nitrogen, we have 3 of those, and the atomic mass of that is 14. Plus 5 of oxygen, we know that's 16. And then we have 1 sulfur, which is 32. So now we can go ahead and multiply these across, then add them up. 12 times 16, if we punch that into our calculators, we will get 192. 19 times 1, just 19. 3 times 14, you know that's 42. 5 times 16 is 80. And then the lone 32 for that sulfur. And we can add these all up, punch into our calculator. And all day, baby, we get 365 days a year, right? 365 grams of basically amoxicillin, C16, H19, N3O5S. All right, so I hope you guys enjoyed that video and really got a quick brief overview and some good practice of how to calculate some molar mass. Again, guys, please go ahead and subscribe, like, comment, ask any questions. You know, it really does support the channel. I'll see you guys next time. Take it easy. Peace.